You know that feeling when you're staring at a loan statement and you just wonder, how long is this actually going to take to pay off? It feels like a big, unsolvable mystery, doesn't it? Well, today, we're putting on our detective hats. We're going to take a super common loan situation and use it to unlock the power of a math concept that, yeah, it can look a little scary at first. But trust me, it's the master key for solving these kinds of puzzles. All right, let's jump right in.
So here it is, our case file. We've got a $120,000 loan. Now that's a pretty realistic number, right? Could be a small business loan, part of a mortgage. A lot of us will see a number like that in our lifetime. But here's the thing. Just knowing the total amount, that's not enough. To crack this case and figure out the time, we're going to need a few more clues.
And here they are. Let's meet the key players in our little drama. First up, you've got the principal, P. That's the big one, the $120,000 we borrowed. Then there's the annual interest rate, R, which is 4.8%. We're making a monthly payment, M, of $720. Now here's a key detail. That interest is calculated monthly. So we take that 4.8%, divide it by 12, and we get our monthly interest rate, which we'll call I. That comes out to 0.004. So, the one character still hiding in the shadows? That's N, the total number of payments. And that's the mystery we're here to solve.
Okay, so to solve any kind of mystery, you really need a map, right? Something to guide you. For us, that map is a formula. It's the one thing that connects all these numbers we just talked about. Let's go ahead and unfold it.
Whoa, okay. I know what you're thinking. That looks intense. But don't click away. This is just the standard loan formula. It looks complicated, but all it's really saying is that your monthly payment, M, depends on the principal, P, that monthly interest, I, and our mystery guest, N, the number of payments. Our entire mission here is to rearrange this thing to get N all by itself. But see where N is? It's stuck way up there in the exponent. And that one little detail, that's the whole reason this is a challenge.
So to really get why that exponent is such a big deal, we got to do a quick sidebar on two kinds of growth. First, there's linear growth. Super simple. It's when you just add the same amount over and over, like putting 50 bucks in a jar every year. Easy. But then there's exponential growth. That's a whole different ballgame. Instead of adding, you're multiplying by a percentage. It means your money doesn't just grow, the growth itself starts to grow.
And guess what? That's exactly how loan interest works. The bank isn't just tacking on a flat fee every month. Nope, they're charging a percentage of whatever you still owe. That's what compounding is. It's exponential growth working against you. And it's the reason we can't just use simple addition or subtraction to find N. We need something stronger.
All right, time to roll up our sleeves. We've got this big, messy formula, our map, and the first thing we need to do is clean it up. We're going to use some good old-fashioned algebra to just get rid of the clutter and see if we can find a clearer path to our answer.
Okay, first things first, let's plug in the numbers we actually know. We know the payment is $720, the principal is $120,000, and that monthly interest rate is 0.004. See that fraction on the top right? Let's just deal with that. 120,000 times 0.004, that gets us 480. Bam! Just like that, the formula already looks a little less scary.
Okay, now for a really clever algebra trick. You see that 1.004n part? That's the annoying bit, right? So here's what we're going to do. We're going to temporarily hide it. Let's just call that whole thing x. It's a classic move. By making this simple substitution, we can turn this messy equation into something that's way, way easier to handle.
And check this out. Once we make that swap, it's just a few steps of algebra we all remember. We multiply both sides by x minus 1, we move some numbers around to get all the x terms on one side, and when the dust settles, all of that initial mess boils down to one beautiful, simple statement, x equals 3. That's it.
So now let's bring our original piece back into the puzzle. Remember, we said x was just a placeholder for 1.004 to the n, and we just proved that x is 3. So that means 1.004 to the n has to equal 3. I mean, how cool is that? We took that monster formula and shrunk it down to this clean, simple equation. But we've hit a brick wall, a big one. How in the world do you solve for n when it's stuck up there in the exponent? This is where we need a special tool. This is where the hero of our story makes its entrance.
And that special tool, the key that unlocks this whole thing, is the logarithm. Seriously, this is what logarithms were invented for. They're designed for this one specific job, to get an exponent out of jail.
So what on earth is a logarithm?
The simplest way to think about it is that it's the opposite, the inverse of an exponent. Look at the definition here. Saying log base b of x is y is just a different way of saying b to the power of y is x. They're like two sides of the same coin. They express the exact same relationship, just from a different angle.
So if you take away one thing, let it be this. Logs are exponents. That's all they are. When you see log, your brain should just translate it to the question, what exponent do I need to raise this base to get that other number? That's the whole game.
Okay, let's put this into action with our problem. We have 1.004 raised to the power of n equals 3. So our base is 1.004. The exponent we're looking for is n, and the number we want to get is 3. If we just rewrite that using the log definition, we get this. N equals log base 1.004 of 3. And boom! Just like that, n is all by itself. We've basically solved it.
But wait, there's more. What's so cool about math is there's often more than one way to get to the answer. Check out this second path. There's a rule with logarithms that says you can just take the natural log, that's the ln button on your calculator, of both sides. And when you do that, another magic rule lets you take that exponent n and just bring it down in front. Then all you have to do is divide. And would you look at that? You get the exact same formula for n. Two totally different methods, but they both lead to the same destination.
All right, the hard part is over. We've got our formula, we've got our tools. It's time for the final step. Let's grab a calculator and finally get the answer to our big mystery. How many months until we're finally free of this loan? So we punch it in, the natural log of 3 divided by the natural log of 1.004. The calculator does its thing, and it spits out our raw number.
And that number is about 275.2. Okay, so we have our number. But what does that mean? I mean, you can't go to the bank and make 0.2 of a payment, right?
Exactly. The real world of dollars and cents doesn't deal in payment fragments. The math gives us this perfectly precise number, but we have to translate it back into reality. So what's the deal with that leftover 0.2?
Well, it means we have to make 276 payments. Think about it. After 275 full payments, you've almost paid it off, but there's still that little bit left over. That's what the 0.2 represents. So you have to make one final, smaller payment to wipe the slate clean. That's why with loans, you always round up to the next whole number.
So 276 months, let's convert that into something we can really feel. Divide that by 12 and you get 23 years. There it is. The case is closed. That $120,000 loan with those terms will take exactly 23 years to pay off. We started with what looked like an impossible formula, but with a bit of algebra and the incredible power of logarithms, we cracked it.
And really, that's what this is all about. The answer, 23 years, is cool. But the real takeaway is that you now see the tool, the key that unlocks any problem like this, whether it's a loan you're paying down or an investment you're watching grow. So I'll leave you with this question. Now that you know how, what's the next financial mystery you're going to solve?